Fluid Mechanics 1, SEMM 2313. So we will see a lot of tutorial here. Question number 1. The water flow rate Q is in an open rectangular channel can be measured by placing a plate across the channel as shown below. This type of a device is called a weir. The height of water H above the weir crest is referred to as the head and can be used to determine the flow rate through the channel. Assume that Q is a function of the head H, the channel width B, and the acceleration of gravity G. Determine a suitable set dimensionless variable for this problem. In some laboratory tests, it was determined that if B is equal 0.9 meter and H equal 10 centimeter, then Q is 0.07 meter cube per second. Based on this limited data, determine a general equation for the flow rate over this type of weir. So in this question, we need to comes out with a mathematical expression or mathematical equation to determine the Q, the flow rate. So from this equation, how to determine the subject in this question? So it is very simple. You just see the word is a function of. So if it says that Q is a function of, so means Q here will become the subject, means something that we need to solve. So and then it says that it is function of head, channel width, and the acceleration of gravity. So means that we could find from this equation, from this question, there is only 4 parameters, which is Q, H, B, and the gravity. So and then what we need to do is we write the mathematical expression like this one. So Q is the function of H, B, and G. So and then we list all that 4 parameter and we list all the MLT system for all these parameter. So and then we categorize all the parameters. So Q will become the main subject here. So means that for sure it cannot be a repeating parameter. It will become the non-repeating parameter. And then for L here, we have 2L, and this 2 is actually geometry. So, and then we need to choose one of these, we need to choose one of the geometric group here as the repeating parameter. So between H and B, so we found that H is the most influenced parameter. So we take H as the repeating parameter and we put B as the non-repeating parameter. And then for kinematic, we only have gravity. So for sure, gravity will become the repeating parameter. So how to determine whether H or B is the most influenced parameter? You need to see from the situation. You cannot remember or you cannot just choose the parameter. So for example, we have this situation. So we found that if the H is different, so it will give different value of velocity. However, if the B is shorter or the B is longer, means it will not change the value of V, because the width here is actually not so influence the velocity. Why velocity is very important? Because to calculate the Q here, the subject, we need to know the velocity. And this velocity is changed when the value of H become larger or become smaller. That's why we need to take NH as the repeating parameter. So and then we need to calculate how many pi terms. So the rule of thumb is very simple. So we list how many pi term we have. So we have 4. And then how many groups we have here. So how many repeating parameters. So we have 2 repeating parameter. So mean we minus with 2. And the answer is we need to solve 2 pi terms. There is only 2 pi terms. And that pi term is this one. So we have pi 1 as q times hg, h to the power of a, and g to the power of b, and pi 2 is b times h to the power of a and g to the power of b. So this is the non-repeating and this is the repeating parameter. So you could see that this repeating parameter is actually being used again and again. Okay, and then this step, I hope you could do this. So we need to find what is the value of a and b. So we are using we substitute the MLT for pi 1, q, h, and g, and we do the simultaneous solution. So we could get pi is equal q over h with the power of 5 over 2 and g with the power of 1 over 2. So, and then we could calculate for the pi 2 here. So, this is the mathematical expression. So, we substitute it with the MLT and we could get that pi 2 is equal to b over h. And then finally, we need to write in this term. So, if not, you will not get your final marks. So, we write, because we only have two pi terms, so we write pi 1 is a function of pi 2. So, and then we substitute the value of pi 1 and pi 2 here, so we could get this one. So, we could read this term as this one. So, we could say that q over h 5 over 2, g 1 over 2 is a function of b over h. So, means that this term is actually changed. The changes of this term is depend on this parameter. So this is the meaning of is a function of. So and then, according to the question here, so we found that this researcher do some experimental work. So and it has a limited data and we could derive an equation from this limited data. So how to derive it? Okay, from the Buckingham pi theorem, we could get a term as this one, q over h 5 over 2 and square root g is a function of b over h. So this is the mathematical expression. So it just an expression. So we need to convert it into equation. So how to convert it into an equation? So we just replace the value of f here with coefficient. So this is coefficient or constant. So now it will become equation. So mean that's q over h 5 over 2 square root g is equal c times b over h. Why we need to multiply with the constant to make it equation? Because the idea of function of here is maybe when we change b over h, there is not 100% effect the flow rate here. So it's maybe only 20%, 30% and so on. So because it is not 100% affected the flow rate, so we need to replace the word is a function of with a certain constant. So that constant may be 0.7, for example. So means in general idea, we could say 0.7 is the effectiveness is only 70%. So means that not all the right parameter could change the left parameter, but maybe 70% will be changed if we change the right term, right hand parameter. So this is the meaning of the constant here. So and then when we substitute, we replace the word is a function of with constant here. So means that it become an equation here, but it is not complete. Why? Because the value of constant here need to be found. So and then how to get it? how to calculate the value of C. So we just rearrange the equation here. So the value of C can be written as this one. Q over H 3 over 2 and square root GB. So and then I think you know, so we have a lot of data, a few experiment data. So we substitute into this equation. So we substitute into that equation with B equals 0.9, H is 0.1 meter, and Q is 0.07 meter cube per second into this term. So we found that C here is 0.785. Then we could rewrite the equation here. So we substitute the value of C that we get from our calculation into this equation, and then we bring all these parameter to the right hand side because we just want an equation with the subject here. So the subject is the flow rate, so we make Q here is as the subject, and then we could get it is equal like this one. So you may compare this equation with the equation of rectangular wear in Introduction to Fluid Mechanics section. So I think you still remember, we learned about rectangular wear, we learned about the triangular wear in a fluid dynamics section. So you could go make some revision from that section. You will find that the equation that we get from the Bernoulli equation is almost the same with the equation that we get here. So it's maybe the value here is slightly different, because we get this value from the experimental work, from the data given in the question, but the value that we get from the Bernoulli equation is actually the ideal works. So ideal means there are no friction at all.